Hi guys, a couple of quick tree diagrams will help you make quick work of these probabilities. So using plan number one means we're going to treat with antibiotic A first, which works 60% of the time. And we're interested in the likelihood then that the child is cured. Well, we'll start with antibiotic A. So with antibiotic A, we get cured 60% of the time. That means 40% of the time it will fail. Now, if you've been cured, you don't need to treat again. If antibiotic A, though, fails, then we use antibiotic B. So here is antibiotic B. It will cure 90% of the time. That means 10% of the time it will fail. So there's our simple tree diagram, and we're looking for the probability that the child is cured. So the child could be cured on the first round of antibiotics, that's antibiotic A. That would happen at a rate of 60%. So if antibiotic A fails, that happens 40% of the time, then antibiotic B will cure the infection 90% of the time. So assuming that A has failed, that's a probability of 0.4, then the probability that B cures them is 0.9. There we go. I'm not interested in the two options where both antibiotics fail. So this is 0.6 plus 0.36. So the probability of being cured is 0.96. You could also think of it this way. The only option you don't want is for both of the antibiotics fails. So you could think of this as 1 minus 0.4 times 0.1. That would also give you 0.96. So using plan number two, understand plan number two starts with antibiotic B. And then we switch to A. So fine. With antibiotic B first, we get cured 90% of the time. With antibiotic B, we fail 10% of the time. So if it fails, that means now we're going to switch to antibiotic A, where this will cure the infection 60% of the time, and it will fail 40% of the time. So again, the probability of being cured, 90% of the time will get cured with the first round of antibiotics, but 10% of the time that will fail. So if it has failed, we will treat with antibiotic A, and that will cure 60% of the time. So this is 0.9 plus 0.06, that's 0.96 again. So the two probabilities end up being exactly the same. The other way to do this second probability, you could also do 1 minus the probability that both antibiotics fail. But notice again, just like up here, 0.4 times 0.1, you have the same thing, 0.1 times 0.4. Both antibiotics fail, assuming independence, 4% of the time. So 96% of the time, we'll have a cure.